What is the purpose of studying one-to-one correspondence? Many things around us come in pairs. For example, male and female animals make a pair, and plants need both the pistil and stamen to pollinate. Many things in our daily lives are fully useful only when they are in pairs, such as forks and knives and bolts and nuts. Pairing up is not only an instinctive behavior in nature, but it also the means to increase the usefulness of various tools. Every pair in nature breeds. During the dry season, wildfires sometimes occur due to friction between branches. Countless living organisms, including plants, die in face of wildfires. However, there are some plants that await wildfires. Shilajit, Casuarina sp, and jackpine, Pinus banksia cones open and reseed only in high temperatures above 200 degrees Fahrenheit. These plants know that there is an updraft during wildfires. The seeds of these plants have wings which allow them to ride the updraft to fly up into the sky and disperse far away. Why do these plants disperse their seeds in such a unique way? The reason for the dispersal of seeds after a wildfire breaks out is because the dead trees that would have been competition under other circumstances provide rich fertilizer, allowing the seeds to grow. The new plants can also get sufficient sunlight that the competitors would have monopolized. In other words, these plants make good use of the time the competition is sparse because of the fire, spread the seed and sprout. This is why some plants await wildfires. What is the biggest organism alive on Earth? Many know it as the blue whale. It is actually the giant sequoia tree. These trees can withstand wildfires very well and become impressive sizes. Giant sequoia trees, which are around 100 meters tall, have many burns from fires. There is a record that one of these trees experienced above 80 wildfires, one of which lasted for as long as a week. These trees can be up to a meter wide, and what is intriguing is that their barks are soft, not hard like many other trees. Their barks are soft rather than hard because this allows them to retain moisture to withstand fire. The reason they must withstand the fire is for the ultimate goal, to disperse the seeds and reproduce. Giant sequoia pines also only open in temperature above 200 degrees Fahrenheit. Firefighters in national parks that are largely populated by giant sequoia sometimes set fire to the forest once a year to stimulate the germination. To trees that can withstand fire, the fire itself is good fortune. Giant sequoias have been able to continue to survive and form large forests by turning a crisis into an opportunity. Plants lay down sideways in the wind. They do not keep their stems upright when it is windy. They deliberately grow in the direction of the wind so as to naturally avoid the wind. Although plants cannot move around like animals, they still do react sensitively to the changes in the environment around them. The taller the plant grows into the sky, the more likely they will be faced with the wind. Plants also have to work hard to get a chance at survival. For example, dandelion seeds are arranged in a round shape so that the seeds can still fly away regardless of the direction of the wind. Plants use the forces in nature to disperse their seeds and reproduce. Water just as important as wind for plants to survive. Marsh marigold, Caltha palustris, is a plant that grows well in water. Once the flower fades, a seed pod grows and opens up once fully matured. All seeds in the seed pod face the sky. At this point, rainfall can hit the seed pod, and the concave shape of the seed pod makes the seed fly into the air. The seed then falls into the water and moves away. Once it reaches a water bank, it starts to grow there. Another plant uses forces even stronger than wind and rain to disperse their seeds. Poison bulbs, Crinum asiaticum, grows a single stalk in July. Multiple flowers bloom from the stalk, and the seed pod starts to grow once its fragrant flower falls. Around 20 rounded seed pods swell up to the size of a walnut, at which point the stalk cannot withstand the weight and fall to the side. When this happens, the seed pods that fall to the ground separate, and gravity rolls it down to the ocean at lower heights. Poison bulb seeds are heavy but buoyant, allowing it to float away in the ocean. In the northern hemisphere with 4 distinct seasons, temperatures during the day stay above freezing temperature but drop below it during early winters. During the cold winter and nights, the living roots of the till leaf Isidens, Isidinexis, pump up water from the ground, but the stems above ground freeze and tear up from the cold. The observers can see the till leaf Isidens only for a few days a year, as the frozen stems soon also make it impossible for the roots to continue to pull up water. These plants willingly submit themselves to death for a new life. Even as most plants die during the coldest of winter, the mistletoe, Viscum album, bears fruit. Why would the mistletoe bear fruit in the winter? Mistletoes disperse their seeds with the help of birds. It is difficult for birds to get food during the winter. At the same time, winter is the time when the leaves that had blocked the view of the birds fall, leaving the branches bare. The mistletoe bears light yellow fruit so they can be easily spotted by the birds. These fruits are also just the right size for browner bulbuls to eat. The browner bulbuls disperse the seeds away into the world. Even mistletoes who seem to have an easy life faces some problems. Because mistletoes are parasitic, they must be attached to the branches to survive. That is why their seeds are sticky, so they can stick to the branches. Mistletoe seeds also have a string that stretches up to 1 meter wrapped around the seed, and birds cannot digest the string. When the bird eats the fruit and lets out what is left after digestion, the spider web-like sticky seeds cling onto a branch. As soon as it starts to get windy, the seed survival instinct comes into action. The seeds blow with the wind and attach itself to a branch, take root in it and sprout. Mistletoes knew where their seeds would go and made preparations ahead of time. Some plants have seeds with timers. While the timer is off, the seeds do not germinate, and sometimes animals are the ones that activate the timer. Mountain goats in Asia eat the fruits of Japanese raisin trees, Hervinia dulcis. The germination rate of Hervinia dulcis is only 3%, they rarely sprout, because their coat is very thick and hard. But, when the mountain goat seed and excretes the seed, the germination rate jumps up to 30%. The strong acidity of stomach acids of mountain goats thins the seed's thick coat. As the coat thins, the mountain goat moves around the mountain and the seed waits for the right time to germinate. Once the seed is excreted, it means the seed has successfully traveled and would be able to avoid tough competition for survival with the parent plant. That is why the seeds of Japanese raisin trees have timers to sprout after moving a certain distance. The excrement of the mountain goat adds additional fertilizer to help the seed sprout better. Such strong survival abilities of the seeds can even destroy human civilizations. Trees sprouted on various rocks of a temple, finding water in the cracks, eventually starting to destroy the temple. Today, it is the trees that are supporting the temples. As the trees and the temple became one, the temples would collapse if the trees were to die. The trees preserve the legacies of the civilization in supporting the temple. Fig trees are another plant that uses the help of animals to disperse their seeds. There are 700 types of fig trees around the world. Out of those, in Borneo, there are fig trees that bear fruit on the ground. Why do ficus uncinnatus bear fruit on the ground? Wild boars have the tendency to dig around for food. Ficus uncinnatus are well aware of such tendencies. Plants have select animals that disperse their seeds. Plants know exactly which living organism they should pair up with. This is how plants reproduce and survive in such many different ways. Observation is the first step in mathematics to discover secrets in nature. We can discover patterns by closely observing plants. Patterns are traces of life and deaths of plants. We can understand each plant's unique characteristics by understanding their patterns. However, it is not easy to predict the life and death of plants. That is why people have assigned numbers and letters to drawings of patterns they have observed. Here, the patterns and numbers form a one-to-one correspondence. People have been able to do various complicated calculations as they started using the abstract numbers in their heads. Although people in primitive societies did not use numbers like we do today, they knew how to count using one-to-one correspondence. One-to-one correspondence refers to matching each element in one group to an element in another group. One-to-one correspondence makes it possible to tell which is more even without the knowledge of numbers. For example, how would someone who does not know numbers figure out which of two pouches with marbles inside has more? They can do so easily by using one-to-one correspondence. If you take out a marble from each packet as a pair, eventually one side will run out first. This naturally shows us that the side with marbles left has more marbles than the other. If we were to take out a marble at a time from each pouch and make a pair, one side will eventually run out first. This naturally shows us that the side with marbles left has more marbles than the other. One-to-one correspondence allows us to count without accounting till numbers. When we ask children how many toys they have, we see them match each toy to a finger and then show us with their fingers, saying this many. The primitive people counted in the same way. In fact, scholars think they went further and used pebbles instead of fingers or made marks on sticks to count. Then why do we study such mathematical concepts? It is not just simply to understand the facts that we can count without using numbers by using one-to-one correspondence. It is to understand how the concept of one-to-one correspondence connects unrelated subjects to form the basis of a useful mathematical tool, functions. The biggest characteristic of one-to-one correspondence is that the knowledge of one side allows us to figure out its pair right away. For example, each of our friends has a name. As soon as we see a friend's face, the name of the friend pops up in our minds. Likewise, once we hear a name, we think of a face. Therefore, regardless of how disorganized a group of figures we have is, we would be able to explain the characteristics of the group if we could pair it with natural numbers using the characteristics of natural numbers. What is the logical explanation of one-to-one correspondence being the basics of calculations? Various studies show us that people in primitive societies already had a basic concept of numbers. The need for the ability to count would have increased as society developed. For example, primitive tribes would have had to know how many members they had in their tribe. They would have used the concept of one-to-one correspondence. At first, they would have counted by folding their finger for each livestock or person. Then they would have gone on to using pebbles or sticks, made markings on the ground or on rocks, or marked lines on sticks to express numbers. A bone with tally marks found among a group of ancient artifacts in the Czech Republic supports this assumption. The Incan Empire and Peruvian regions of South America today express numerals by tying knots on strings. Counting methods that had used objects in nature progressed to one that used sounds. Think of a child who did not know numerals and used to express 3 by holding 3 fingers up, starting to use the word 3. Once words describing numerals came about, symbols and numbers that helped express numerals even more conveniently would have been created. Most of our ideas on the primitive concept of numbers or counting methods are based on assumptions, but various artifacts that have been excavated support these assumptions. It took a long time for humanity to come up with numbers and start to utilize them, but there is no doubt that this is an incredible gift that only humans have. That is, the ability to find common characteristics between different objects and use such characteristics as if dealing with objects became a force that allowed human societies to achieve such development. One-to-one correspondence is the most basic and simplest way to count. However, when there are many things to count, using one-to-one correspondence to count or record is a tedious task. So, people came up with a way to think of a set size or amount as a group when expressing it in numerals. For example, they came up with a way to count in groups of 5 using their fingers. They folded a finger on their right hand for every item counted. Once all 5 fingers were folded, they would fold one finger on the left hand and unfold their fingers on the right. Using this method, we can count up to 30 using 10 fingers. If 3 fingers on the left hand are folded and 2 fingers on the right hand are folded, it would mean 5 plus 5 plus 5 plus 2 equals 17. Calculation is needed even when we count the number of cases a certain event can occur. Probability refers to a numerical representation of a chance event or uncertain things. To calculate probability, we need to get the number of cases first. Then, how can we calculate the number of cases when an event consists of 2 other events? In this case, we have to first figure out whether the 2 events can occur separately or not. If one event cannot occur separately from another event, we could say that the 2 events occur simultaneously. In this case, the rule of multiplication has to be applied. The rule of multiplication refers to the rule that the number of cases of the event A and B occurring simultaneously is m times n when there are m ways of the event A occurring and n ways of the event B occurring. For example, imagine that there are 4 routes to choose from when going to Boston from San Francisco. At the same time, there are 3 routes from Boston to New York. In this situation, what is the number of routes that can be taken from San Francisco to New York? To go to New York from San Francisco, we have to stop by at Boston. Therefore, the event of going to Boston from San Francisco and the event of going to New York from Boston cannot occur separately. We can know that the rule of multiplication has to be applied in this case. There are 4 ways to go to Boston from San Francisco and 3 ways to go to New York from Boston. Thus, the number of cases of going to New York from San Francisco is 4 times 3 equals 12. Throw a dice once, then throw it again. If we were to throw the dice twice this way, what is the number of cases where we get to even numbers in a row? The number of ways we can get an even number the first time we throw the dice is 3 because a dice has 3 even numbers, 2, 4, and 6. The number of cases we would get an even number in the second throw is also 3. To get an even number twice in a row, we need an even number for the first throw, and an even number for the second throw, as well. Because these 2 events cannot occur separately, the rule of multiplication has to be applied. Thus, the number of cases of getting an even number consecutively when throwing a dice twice is 3 times 3 equals 9. What about the total number of cases in 2 consecutive dice throws? The numbers we can get from a dice throw is 6, from 1 to 6. At the same time, the first dice throw and the second dice throw are consecutive events that cannot be separated, meaning that the rule of multiplication is applied. The total number of cases from 2 consecutive dice throws is 6 times 6 equals 36. Now, what is the probability of getting an even number consecutively when throwing a dice twice? The probability is a ratio of the number of cases of a given event occurring to the total number of cases of an event. We can divide the number of cases of getting an even number consecutively, 9 cases, by the total number of cases, 36 cases, when throwing a dice twice. Therefore, its probability is 9/36 equals 1/4. This time, let us look at the rule of sum. This rule is applied in the case where 2 events can occur separately, and cannot occur at the same. The rule of sum refers to the rule that the number of cases event A or the event B occurs is m plus n when the number of cases the event A occurs is m and that of the event B occurs is n. For example, suppose a person living in Beijing plans to have a vacation either in Paris or London. From Beijing, there are 4 ways to go to Paris and 3 ways to go to London. In this case, what is the number of cases of going to Paris or London from Beijing? The events of going to Paris from Beijing and going to London from Beijing cannot both take place. That is, since it does not matter whether he goes to Paris or London from Beijing, the rule of sum has to be applied. Hence, the total number of cases that allows the man to go to either Paris or London from Beijing is 4 plus 3 equals 7. A university has clubs, each of which has a room in the student union building. There are 3 clubs on the first floor, 5 clubs on the second floor, and 6 clubs on the third floor. What is the number of cases for a student to choose among the clubs in the student union building? The students can choose either to choose a club on the first floor, the second floor, or the third floor. The possible number of cases for each event is 3, 5, and 6 respectively. If this student chooses a club, he cannot choose among other clubs. This means that the rule of sum has to be applied here. We can learn that the number of cases he can choose a club at the student union building is 3 plus 4 plus 6 equals 14. We need to be careful when we calculate the number of cases using the rule of sum. We need to look carefully to see if there are ways for two events to take place simultaneously. If there is, we must subtract the overlapping event. We can explain the rule of sum through sets. Suppose that A is the set of the number of cases where one of two events occurs is the set A, the set of the number of cases where the other event occurs is the set B. In this case, the rule of sum is the same as finding the union of two sets. The number of cases of two overlapping events, meaning that two events both occur, corresponds to the intersection of two sets. Therefore, to get the union of two sets, we need to add the set A and set B, and then subtract the intersection of the sets. As such, whenever we are calculating the number of cases where two events can occur by applying the rule of sum, we must look for the number of cases in which two events occur simultaneously. The four basic arithmetic operations help us to have a better understanding of mathematics. We see many different mathematical formulas as we study mathematics. Why were these formulas made? Is it simply to make the calculation easier by memorizing the formulas? In fact, mathematical formulas have a significant meaning. In particular, they can be used as an effective tool to solve certain mathematical problems. When students move on from elementary school and enter middle school, they start to learn the four basic arithmetic operations of integers. We may be getting slightly ahead of ourselves, but let us take a look at the multiplication of integers among the four basic arithmetic operations. In particular, try to figure out why the multiplication of two negative numbers like -3 times -2 equals 6 becomes a positive number. Students usually first learn about multiplication when they are in the lower grades in elementary school. They learn how to do multiplication by counting groups in relation to addition. The multiplication is explained using the number of groups and the number of elements in each group. In this sense, 3 times 2 can be read as 3 groups with 2 elements in each group or as 2 groups with 3 elements in each group. Thus, 3 times 2 equals 2 plus 2 plus 2 equals 3 plus 3 equals 6. This is an example of positive number times positive number equals positive number. We already know this. What happens if positive number times negative number? For example, 3 times -2 is the same as there are 3 groups with -2 in each group or as -2 groups with 3 in each group. When we express it in an equation, it becomes 3 times -2 equals -2 plus -2 plus -2 equals -3 minus 3 equals -6. This tells us that positive number times negative number equals negative number. Lastly, let us look at what happens for negative number times negative number through -3 times -2. We may say -3 times -2 can be thought of as -3 groups with -2 in each group or as there are -2 groups with -3 in each group. This can be written in as the following equation: -3 times -2 equals -2 minus -2 minus -2 equals -3 minus -3 equals 2 plus 2 plus 2 equals 3 plus 3 equals 6. That is, negative number times negative number equals positive number. Then, why does mathematics use the multiplication? Using the multiplication sign, We can avoid arranging the same number repeatedly with the plus sign and simply express this in the form of multiplying two numbers. In addition, multiplication allows us to save time by avoiding the repeated addition of the same number. Simply put, the multiplication helps us to calculate easily. How could we use the concept of the one-to-one correspondence? What are some examples of one-to-one correspondences used in our daily lives? Think of a vending machine, where there are a variety of beverages, each of which has a button under it. We can insert bills and push a button under the beverage we want to have, and the bottle or can the same as the one on display drops out. That is to say, the button and the beverage are in the one-to-one correspondence. We can also find one-to-one correspondence on the computer keyboard. When we press a key, the letter corresponding to the key shows up on the monitor. The one-to-one correspondence is widely used in games, too. We play the game of ladder in Asia to decide who goes in what order or to determine who gets a prize or. We can start the game by drawing vertical lines according to the number of players and draw random horizontal lines between the vertical lines. On one side of the vertical lines, write down the name of prizes, penalties, or order and cover them up so the players cannot see them. On the other side of the vertical lines, the players can choose where to write their names. Once all vertical lines are chosen, everyone gets to follow down the vertical line following a simple rule. Whenever a player comes across a horizontal line as they move down the vertical line, the player must move sideways along the horizontal line. When the player meets the next vertical line, he or she must continue along it downward. Once everyone comes to the end of the vertical line following these rules, the players know what their prize, penalty, or order is. In this game of climbing the ladder, there will never be a situation where two different players start from different places and end at one point. This is because the starting point and end point are in the one-to-one correspondence. We are very familiar with counting in groups of 10. However, computers process data in groups of 2. In other words, computers can express every number and letter only with 0 and 1. They use the binary system of only 0 and 1. We use the decimal system, with 10 numerals from 0 to 9. One of the reasons why computers use the binary system is for electrical and mechanical reasons. Using the binary system is helpful to reduce errors in computer systems. It is crucial to reduce errors because the errors in the data transmission process can corrupt the original data. In computers, 1 represents the presence of an electrical signal and 0 represents the absence of an electrical signal. If computers used the decimal system as we do, electrical signals would have to be divided into 10 levels. For example, suppose the voltage level of the electrical signal is from 0 to 9 volts, and computers express digits from 0 to 9 accordingly. The problem is that it is difficult to accurately transmit the voltage of the electrical signal in the unit of integers. If a computer received an electrical signal which is slightly higher than 1 volt, the computer could process it as 1 volt and transmit the digit 1 or as 2 volts and transmit the digit 2 because the signal was greater than 1 volt. As such, to reduce errors in data transmission, the computers use the binary system, representing the digit 1 when there is an electrical signal and the digit 0 when there is no electrical signal. This time, let us look at the secret of barcodes that contain the concept of one-to-one correspondence. On the packaging of products used in our daily lives, we can easily see barcodes consisting of black lines and white gaps. When we go grocery shopping, we choose and put items on a checkout counter. A clerk would read barcodes using a barcode scanner, which beeps and the price of the items are displayed on the monitor. Thanks to barcodes, it became no longer necessary to enter every single data of products one by one. Why does a barcode use the shape of sticks instead of numbers? The barcode uses the black and white lines so that computers, which represent information using 0 and 1, can read the information easily. By the way, why are there seemingly meaningless numerals below the barcode? Sometimes, the barcode scanner does not work, and a clerk may have to type the numerals in barcodes one by one using a keyboard when the barcodes were not readable. That is, the numbers are there in case barcodes cannot be read because they are erased or damaged. Barcodes are usually made up of 13 digits and each digit has a different meaning. The very first 3 digits show the country the product was manufactured in, the following 4 digits represent the manufacturer, the 5 digits that come after indicates the unique code for the product. The final numeral is a check digit to verify whether the preceding digits are right or wrong. This check digit is determined by the first 12 digits. The check digit can be calculated by adding the sum of digits in the odd-numbered places and the sum of digits in the even-numbered places multiplied by 3. The final sum becomes a multiple of 10. Some people may think that barcodes are too complicated to understand. However, when we look into them through mathematics, we can know that the principles of barcodes are very simple.